Good afternoon, everyone. My name is Bo Xiong from UT Austin. I'm going to present our recent work on text detection in stores using a repetition prior. This is a joint work with Kristen Grauman. The goal for text detection is to localize any arbitrary text in a scene, regardless of its size, font, or any specific content. Most existing work on text detection focus on outdoor images. However, text detection in stores has been largely ignored. Look at these two types of images and know they're actually quite different in nature. Images from street side scenes, they contain text that's normally featured in a sign or the side of a building, whereas in stores, text printed on a product are often appear within substantial clutter. And we study the problem of text detection in stores. And to the best of our knowledge, this is the first work that specifically targets indoor environment. Why is text detection in store an important problem? Well, it has many potential applications. For example, it enables assistant technology to help visually impaired users. And with wearable platform, it can also help to retrieve relevant product reviews and also help to complete shopping lists. However, text detection also presents its own challenges. For example, text of store shelf often contain a high density of text occurrences, and many products they share design pattern and that have similar texture as text. So basically, those two factors would create a lot of false positives, even for today's best text detectors. While the high density of products on the shelf creates many nuisances for a text detection system, we observe the same density can also provide a very helpful factor. Each product often appears multiple times on a shelf, side by side. And our key insight is those duplicate occurrences of text can be a very valuable prior for a text detection. So look at the images here. A word appear multiple times in this image, and detecting these individual occurrences is going to be pretty hard because of occlusion, viewpoint variation, and illumination. So by utilizing the proposed repetition prior, we can actually detect these text regions together, because detecting of one will help detection of the others. Here is an overview of our approach. Given an input image, the first step is to generate an initial set of text regions proposals. And for this step, any existing method can be used. And we use a state-of-the-art text detector method based on deep learning. And then the next step is to identify similar candidate boxes. And we pose the problem of detect repetitive patterns as finding connected component in a graph. Finally, we want to further improve recall by augmenting the detection with regions that are ignored by the initial text detector. And this step is done by local feature matching. We test our dataset. We test our method on two datasets. The first one is the grocery product dataset, which consists of images taken at 5 different stores with a mobile phone. And the second one is the glass video, which is captured by a wearable camera on Google Glass. By the way, the annotations are available on our web page. If you are interested, please try the annotation. So we compare our method with 3 existing baselines, including the stroke width transform, a method based on MSCR region, and the state-of-the-art method based on deep learning. We outperform all baselines, including the ones of deep learning, and our method outperforms the deep learning-based method by more than 28%. And this is a very important empirical finding because our method directly operates on the output of the deep learning-based method. And this confirms that by jointly doing the text detection, we can definitely improve both the precision and the recall. And here are some examples of text detections. Our method is able to find and ranking the repeating words more confidently than those non-repeating candidates. And by joining detect text regions, we can significantly improve performance. And here are some more results. For more details, please visit us at the poster session. Thanks for your attention.